This lesson introduces basic plotting. We start by introducing a matplotlib magic that's needed to use plots in Jupyter Notebooks. We then show how we can use the plot command from a data frame to quickly generate plots using data when it's stored either as a series or a data frame. Finally, we show how we can use pyplot to produce plots from NumPy arrays or also from data frames if we don't want to use the built-in plot command. This lesson introduces graphics, particular line plots. Rather than use Visual Studio in this lesson, I'm going to use PyCharm just to demonstrate some of the features of it, which I think are fairly compelling for this course and generally when working with data in Python. So I'll start by opening up the lesson. So we're in lesson 16. And when we open it up, of course, we'll get two panes. We'll see our code and the markdown and some empty cells on the right side. So I'm going to start simply by running some of the cells as needed to get the Jupyter server started. So here I'm going to run a cell that says it's a cell I left in with code, and in particular it has a special command. It says matplotlib inline. So when you use a Jupyter notebook, you need to call this in order for plots to show up in the Jupyter notebook. So if you aren't doing plotting, you don't need this command. But if you want the plots to actually show up inline in the notebook, then you need it. If you want to save the plots or do other things with them, it isn't strictly necessary to use this, although when you're doing interactive work with graphics, you almost always want to have this command entered. So this is a special command. It's called an IPython magic. That's this % and then a keyword. We won't rely on these too much, but this one in particular turns out to be quite important. This assignment asks us to do some basic plotting of some data that is high frequency transaction data. Each one is a single day. So we have one for Microsoft, 1 day of Microsoft and 1 day of IBM. So we're asked to read this data in. The data has been stored in HDF, and we're told we're given the keys. So we're going to use some of the tools that we developed earlier to read HDF data. So I'm going to do import pandas. Let's start by importing pandas. Then we're going to do pd read HDF. The file is located in data hf.hdf, so high frequency HDF. And the two keys we're told are IBM and Microsoft. So my first bit will be IBM. Second one will be Microsoft. So this is pretty straightforward. So when I'm happy with that cell, I can press Control Enter and execute it. You see on the right, I get a star that indicates that the cell is executing. And apparently I don't have this file, so I'll have to go into project, take a look at data. And there you go. So I said it's called an HDF file, but I actually called it an H5 file in the data. So once I fix that, I can rerun it, and you don't really see much on the right side in terms of the output. But one thing you do see is down at the bottom in the variables, you can see IBM and Microsoft. It tells us their series, and it gives a not super great representation of the data. If you click on it, it's not so helpful. But if you click on the right here where it says View as Series, then you actually can see the data in a sort of particular data viewer. You can see you have dates and times with timestamps. It's all the same date, so the only thing that's changing are the hours, the minutes, and the seconds, and the milliseconds, in fact. And you have a lot of prices that, it's an asset price, so the prices don't change too much over very small periods of time. Okay, so that said, I'm sort of happy enough with that, so I'll just close that side viewer. So that's sort of this. We will see this a bit later. You might see this again if you use scientific mode with PyCharm, then you tend to see it. So moving on to the problems, we're asked to do some plotting. So the way we're going to sort of do this plotting is we're going to do the sort of clever way, which is we're actually going to let pandas do almost all of the work. In particular, I'm going to start out with a really basic line plot. So it turns out whenever you have a series, you can always just plot it by calling the plot command. So I'm going to type AX equals IBM. So IBM is my pandas series. I'm just going to type plot. And when I'm done, I'll press enter. And right there on the right side, you can see there's my plot. It has the prices sort of between 168.25 and 170. And there's the sort of dates. The dates aren't particularly useful because, of course, they're not in hours or minutes or seconds. But this is just a really basic way just to get, often when you're working with data for the first time, you want to take a quick look at the data. So the sort of plot command is always available, and it's a really straightforward thing. This is not a really great plot, so we might want to try to improve it a little bit. So another thing we could do is I could plot it again, and we can add a title. So you can see I got this AX out. AX is called an axis. You can actually see it there in PyCharm. It says it's an axis subplot. That's from the previous plot, but it'll be exactly the same type of thing. And from this, I actually have a lot of properties that I can actually call. I can set the title. I'll call it IBM price. I can label the axis. X label is going to be time. And Y label is price. When I'm ready. I didn't like something I did. Just a little typo there. Sorry about that. It should be X label and Y label. And when I'm ready, and again, I can also make the exact same typo in the second one. And finally, when I'm ready, I press Control Enter again, and there is the output. So again, a bit better, a bit more improved, but still it's kind of very basic. But there are a lot of things you could do with plotting, and again, something you need to look into help, and there's lots and lots of options you can do. So for example, if I want to make a line plot that has no line, but uses a marker instead, those options are available. So I can simply type IBM.plot, and I can say I want line style to be none. That says don't actually draw a line. Of course, if I just did that, it wouldn't show me anything in the plot because there'd be no line, there'd be no markers. But then I want to put in a marker, and I'm going to use a downward facing triangle, which symbol for that is V. Again, you can find all this help in matplotlib's help, which is the main plotting library. Pandas just wraps matplotlib and provides a sort of very friendly interface here. So if I just run that, you can see I get a slightly different plot. In particular, there's no line. You can see a few gaps here and there. And you can also see that there are clearly markers, in this case, downward facing triangles there. If I change the marker, say to an O, and I rerun it, you'll see circles. It's not so obvious they're circles, but they are circles. If I change it to a caret, for example, you will get upward facing triangles. So there's lots of symbols you could use here. It's not incredibly important to sort of use a particular one, but these are all available. A more useful plot often is to make what's called a subplot. So subplots allow us to see more than one thing at a time. They allow us to see, say, two series at the same time. For example, we might be interested in seeing the Microsoft and the IBM data at the same time, and sort of just seeing what do we see when we compare across the two. So to do that, if we want, we can obviously put them on the same plot. That would be one option, but that can be very messy. Prices of Microsoft and IBM are actually quite different, and so it's not easy to put those on the same plot. So instead what we're going to do is we are going to put those in a subplot. So we're going to have essentially it's going to be an array of plots. It's going to be 2 rows and 1 column of plots. So to do that, I need to start by importing matplotlib pyplot as PLT. So this was one of the canonical names I mentioned quite a few lessons ago that we tend to use. I'm also, now that I've imported this, I'm going to use a command which is going to change how the figures appear in the notebook. I'm going to just change the default figure size to be slightly larger. So what this is going to do is it's going to change the default figure size to be bigger, which will just make for a nicer aesthetic. The other thing I'm going to do is I'm going to import a package called Seaborn. So Seaborn is a package that, for me, I use it a lot to improve the aesthetics of plots. In particular, it has a set of predefined styles. I like this one called Dark Grid. that will, use a different set of colors and provide a little grid, which makes it easier sometimes to read plots. Now that I have that done, that's all just sort of set up. None of that is strictly necessary. But what is necessary is to import matplotlib pyplot. And so I'm going to use that to create a figure and some axes using what's called simply subplots. So subplots is a command where I will give it, you can see there, number of rows, number of columns, which defaults to 1, 1. So if you just wanted a 1, 1 plot, you could just call that without any arguments. But in this case, I want 2 rows and 1 column. So it's going to give me the figure handle and the axes as well. The axes is actually going to be a list of axes. There's going to be 2 of them. And so what I then want to do is I want to do just the same, let pandas do the work. So IBM plot. And now though I'm going to tell it to plot it in IBM on axis 0. And I'm just going to provide a little bit of style here. Line width equals 3. I'm going to do the same thing for Microsoft. Except now, of course, I'm going to plot that on axis 1. I'm going to just mostly showing what some things you can do. Line style. So I'm going to change the line style to be, instead of a solid line, to what's called a dash dot line. And I'm also going to change the color to be orange. I could just let that default. It would usually give me a different color. And so now that I'm happy with that, I can do that. And then the last thing I'm going to do is I'm going to use a really sort of helpful command, which is called tight layout. This command will often fix a lot of funny little formatting things. So I do tight layout pad 1.0. This will fix some overlap in some of the figures. It's something I call almost all the time when I'm working on my own work in plots. So now that I'm ready for this, I'm going to run it. And if I didn't make any typos, we'll see we get a sort of improved plot on the right side. It's improved in 2 ways. Obviously, it's bigger, which is helpful. It's also, it also has a grid, which sometimes makes it easier to actually read. If I want to read across, say where 26 is, I can see that very easily. If I want to read across where any of the values are, that makes it easier. So it has a, just a better sort of aesthetic look. So this is the aesthetic actually comes from using Seaborn. The other things come from using this subplot and then plotting on the 2 axes. So this is, again, a really basic way of how you do subplots. Once you create these axes, you can put any type of plot on there. This lesson really focuses on line plots. In the follow-on lesson, we'll look at other plots like histograms or scatter plots. In a subplot, you can put any plot that's actually available into that plot. And so you can have collections of different types of subplots when you're trying to demonstrate certain features about data. So the final part of this assignment asks us to make a plot with dates, and instead of letting pandas do the work, which again, most of the time I would recommend having pandas do the work, but instead of having pandas do the work in this case, we are going to use matplotlib directly. So the way we do a plot in matplotlib is we do plot, and the function is plot. And essentially, we're going to have x comma y. So we need x data and y data. So what do we want to plot? So I want to plot IBM, and I want to use IBM's index. So the IBM index, if I took a look at that, so just take a look at the head of it. Oops, I guess head's not available. Let's look at the first 10 elements. That should work. You can see it's a date time index. And it has, timestamps. So the first one is at 9:29 and 59 seconds, 0.712. The second one is at 9:30 at 19 seconds, 0.5, and so on. So these are high frequency data. So of course they're happening every few seconds. So that's what I have for the index. The index is going to be times and dates. And then I'm simply going to plot what's called the values, which will be the y values. So when you use values on a series, you actually just take essentially the NumPy array out of the series. So once I have that, I could just run that plot and take a look at it. And that's kind of the default styling you get. So this obviously is a bit bigger because it's still relying on that figure size change that I provided a bit above, but it's not as nice in some ways in that it doesn't sort of match the start and the end. So if I want to do that, I need to use one of these commands here in particular. I want to get an axes instance. Well, that's actually not what I want. So what I want to do, sorry. So I want to use a command that's available in matplotlib called GCA, which gives me the most recent set of axes. And then once I have that, I can type axis.set xlim, which sets the x limits, and I can just say I want to have ibm.index0, which of course is the very first element of IBM's index, ibm.index1, which is, -1, excuse me, which is the last element of IBM's index. And then I'm just going to do fig tight layout pad equals 1.0, which is, something I like personally. So I'll run that code. And now we can see this setting the limit has changed things such that I get it. You can see at the bottom you have slightly different times. So in fact, these are dates. So you can see you have the date there, but then you have the hour, 10, 11, 12, 13, 14, 15, and 16. So that's the times, that's the hours, the dates. There are ways to improve the format of the X limit. In particular, if you were actually plotting high frequency data on one day, you'd be much more interested in showing the time, the hours, or the hours and minutes rather than showing what's shown here. Again, we're not going to get too much into detail there. There's lots of help available on how you can format axes. This lesson shows how DataFramePlot or series plot can be used to simply produce basic line visualizations from pandas, data frames, and series. In order to show these plots in a Jupyter Notebook, it's necessary to use the matplotlib inline magic. If you are working in a standalone Python file and you want to see the plots, you need to actually call plot.show. Finally, we saw how plot.plot can be used to directly produce plots, which can be used with either NumPy arrays, or they can also be used with pandas, series, and data frames.